Dear students, myself Dr. S.S. Kulkarni, Department of Physics, KLS Gupta Institute of Technology, Belagavi, will discuss few numericals on wave optics. In wave optics, you have studied different theories of light such as Newton's theory, Heisenberg's theory, Planck's quantum radiation theory. Later, phenomena of light such as indifference, diffraction, polarization. In indifference, you know it's a redistribution in the intensity of light, where you have derived the conditions for constructive and the destructive indifference. And also you have studied indifference due to single slit and Young's double slit experiment and their equations. Diffraction, where you have studied two types of diffractions as Fresnel and the Fraunhofer type of diffraction, and plane diffraction grating. Finally, the last is the polarization of light. Take the first numerical on indifference. Question 1. In an indifference experiment, intensity ratio at bright to dark ring is 9:1. Amplitudes of the interfering waves are in the ratio. The options are A 3:1, B 9:1, C 2:1, D 4:1. We need to calculate the amplitude of the interfering waves when the intensity ratio of bright and dark is given. So you know that I max by I minimum is A1 plus A2 divided by A1 minus A2 raised to 2. The ratios are given as 9:1. That is, bright to dark ring ratio is 9:1. So 9:1 is equal to A1 plus A2 divided by A1 minus A2 raised to 2, which gives the answer as A1 plus A2 divided by A1 minus A2, which is equal to 3/1. If you simplify this, you get the answer as A1 by A2, which is equal to 2/1. Hence, the correct answer is C, which is 2:1. Question 2. In Young's double slit experiment, the distance of the screen is increased 4 times and distance between two coherent sources is reduced half. Then the fringe width will be. The options are A. Increase by 2 times, B. Increase by 8 times, C. Decrease by 8 times, D. Decrease by 2 times. Here we need to calculate the fringe width of Young's double slit experiment. You know the equation beta, that is the fringe width is lambda divided by lambda into D divided by D, where the capital D that gives the distance of the screen, the small d that gives the distance between the sources. Since in the numerical the distance of the screen is increased 4 times, so D becomes 4D, where the distance between the two coherent sources is reduced half, that is 1/2. So if you simplify, that gives beta is 8. Therefore, the fringe width will increase by 8 times. Hence the option is C. Hence the option is B. Question 3. Diameter of the 8th ring in Newton's rings system viewed normally in a reflected light of wavelength 5000 angstrom is 4 mm. Radius of curvature of a convex surface in contact with a glass plate is. The options are A 1.5 meter, B 1 meter, C 0.5 meter, D 2 meter. This is the numerical which is based on Newton's rings experiment. Since you know in Newton's rings the diameter, that is d square, which is given as 4n lambda into r, where d is the diameter of the ring. Here we are going to calculate the radius of the curvature of the lens. So r will be d square by 4n lambda. The diameter of the 8th ring is given, so the number of ring n becomes 8. The diameter, which is 4 into 10⁻³ square, 4 into 8, this is lambda, which is 5 10 raised to minus 7. Then after simplification, the r becomes 1m. The answer is B. Question 4. A slit of width A is illuminated by white light. The first minimum for a red light of wavelength 6500 angstrom will fall at an angle of 30 when, that is A, that's the width will be 3200 angstrom, 6.5 10 raised to minus 4 mm, 1.3 micron, 6.5 10 raised to minus 4 mm. Solution. Since we are going to calculate for the first minimum, so you have the equation for a diffraction grading as A sin theta is n lambda. Since n is 1 because first order, that is a minimum, so A sin theta is 1 into lambda. The values which are given is the wavelength 6500, the angle that is 30, then we need to calculate this width A. So A will be lambda divided by sin theta. Lambda is given as angstrom, so write it as 6.5 10 raised to minus 7 meter divided by sin 30. The answer is 1.3 micron. So the answer is C. Question 5. The refractive index of a medium is √3. If the unpolarized light is incident on it at the polarizing angle of medium, the angle of refraction is. The options are A 60 degree, B 45 degree, C 30 degree, D 0 degree. This is the example based on the polarization. You know, using the equation tan of IP, which is equal to √3, because the refractive index is given as √3. Now IP is equal to tan inverse of √3. So tan inverse of √3, that gives you the answer as 60 degree. But here we need to calculate the angle of refraction. So angle of refraction R, which is equal to 90 minus IP. That is 90 degree minus 60 degree. That gives the answer as 30. So the answer is 30 degree. Answer is C. Thank you.